Hey guys, it's Miss Neely. For day one, we are just going to kind of go over the notes of the last thing that we did in our notebook. So we're not actually going to be taking any notes today. We're just going to kind of review. So if you'll see that this is page 22, you guys should all have this in your notebook. This is writing parallel and perpendicular lines. So we're just going to kind of review because your work today is going to consist of a worksheet that makes you write these parallel and perpendicular lines when you're given a point. So first thing we're going to look at is the parallel lines examples. So I'm going to do my best here. All right. So first thing we have is the question is asking us to write an equation in slope-intercept, which is our y equals mx plus b, form for the line that passes through 6, 2, that's our point, and is parallel to y equals negative 2/3 x plus 1. And then it says to graph both lines. So we've already done all of this, but we're just going to kind of review. So our very first step is to find our original slope. So we know that our original slope is going to be the coefficient of x. That's coming from right here. So m is equal to negative 2/3. The second step we have here is to sub in our x, our y, and our m. Now the reason we can use this m right here that we found in step 1 is because we are asked to find a parallel line. So parallel tells us that our slopes have to be the same. So what we're going to do is we're going to take our equation y equals mx plus b, and we're going to sub in our y value, so that's coming from the point. Our y value is 2, equals our m, which we said was negative 2/3. We found that from our first line, times our x value, mx, right? And our x comes from our point, again, up here. And then we're going to put this plus b because our next step is going to ask us to solve for b. So our b value is our y-intercept. And we know that if we have a slope and a y-intercept, then we can graph a line. So here we go. I just rewrote this down here. 2 equals negative 2/3. And I went ahead and changed my 6, my whole number 6, to be a fraction form. So it was easy to multiply here. So 6 over 1, and then we have our plus b still. You have to do your multiplication first. So we're going to multiply straight across, and I went ahead and kept my negative up here with my 2 value. So I did negative 2 times 6, and I got 12. And then 3 times 1 gives me my denominator of 3. So my new equation, 2 equals negative 12/3 plus b. Now, you'll see this little arrow here. That's because we simplified this fraction here. Negative 12 over 3 actually gave us negative 4. So we ended up with the equation 2 equals negative 4 plus b. So to solve for b, we then added 4 on both sides, and we ended up with our b value equaling 6. So that's our y-intercept, right? So now we have our y-intercept and we have our slope, but it's asking us to write the equation. So we're going to use our slope, the negative 2/3, and we're going to use our y-intercept value, our b. So we have y equals negative 2/3 x plus 6. So the reason it has a little b down here, if you remember, because we graphed our lines. So we graphed our original line. That was our a. That's our original line. And then we graphed our second line, which is b. Now, when you guys do this on your classwork, I want you to use Desmos. So you're going to actually go into Desmos and you'll type this right here. And then you're going to type in the second line that we created. And you're going to check and make sure they look like they are parallel, which means they do not touch. All right. So we're actually going to skip example 2. And we're going to go ahead and go down to example 3 for perpendicular lines. Try to keep these videos short and sweet. So to write an equation in slope-intercept, again, that's your y equals mx plus b, and we're looking for a line that's perpendicular. So remember, perpendicular means that it creates right angles when they intersect. And we're going to create a perpendicular line to y equals negative 3x plus 2 and contains the point 6, 0. All right. So our steps are pretty similar. The only difference is we do have this one extra step, and that's because we have to change our slope here. So our first step is the same, to identify your slope. Again, that comes from your original equation, this coefficient of x here. So we have negative 3. Now it says determine the perpendicular slope. Now, remember, perpendicular means that you have to take the opposite, which means one's negative, one's positive, and you have to take the reciprocal. So that means you're going to flip this number right here. Well, 3 is really going to be equivalent to 3 over 1. So when you flip it, it becomes 1/3. And remember, it does change to a positive. So now here's kind of the tricky part. Some people forget that you have to sub in the new slope when you're going to sub it into y equals mx plus b. So don't forget, you're always subbing in that new slope that you found, that perpendicular slope. So we end up with 0 coming from our point up here is our y value. So 0 equals our slope, m, 1/3, times x, which is again from our point, and then plus b. So next step, solve for b. So again, from this 6 right here, I went ahead and changed it into a fraction form. That's going to help us to multiply there. So we end up with 0 equals 1 times 6 is 6, and 3 times 1 is 3. So that's how I got 6/3 here, plus b. We simplified 6/3. That's our first step. So we ended up with 0 equals 2 plus b. And then you can see we went ahead and solved here. So we subtracted 2 from both sides. So 0 minus 2 is going to give us that -2 value, right? And that's our y-intercept. So as long as we have a y-intercept and a slope, we know we can write an equation and we can graph it. So when we plug it back in, we're only going to plug in our m and our b this time. So we get y equals our slope, which was 1/3 x, and our y-intercept, which was -2. And we did go ahead and come over here and graph them. And we should have labeled over here, this is line B. Okay, and you can see that they do create those perpendicular lines. Now, I do want you guys again to graph these on Desmos. So you will graph this line here. Then you will come and you will hit enter and do another line. And you'll graph this line, this equation. And then hit enter again and you'll graph this point. So this point should be on line B. So on this line, you should see that point 60, okay? And we can kind of see it here too. If we count over, 60 is right here. So that is going to be a point on that line. So that's what you're kind of looking for. All right, guys. So that's just a review. Hopefully you can do the worksheet. I think it's 16 problems today. If you have any questions at all, please feel free to either email me, text me on Remind 101, or you can try Google Chats and send me a little message. I should be on for the entirety of your period today. If you have any questions after that, email or Remind 101 is the best way to get up with me. All right, good luck, guys.